Hi, welcome to the May 31st, 2023 meeting of the CNCF IoT Edge Working Group. On today's agenda, we got a nomination to discuss a white paper draft of behavior for edge native applications. The people who put it on the draft, I think, would like to do that in the second half of this meeting because they said some people would be arriving a little late. So until that happens, we're open to member nominations for other things to discuss. Can be anything from a question to just some topic you became aware of something interesting on, to a question you'd like to have the group resolve. So the floor is open for free-form discussions for anybody who wants to put something on the table. And for the people who wanted to have that white paper discussion, just go in there. I'm not even sure if who's here and who's not, other than I heard that they'd be arriving late. So let's plan on that starting about 9:30-ish, unless somebody in that group who put that on the agenda wants to suggest an alternate time.
That sounds good, Stephen. Yeah, this is Brandon, and it's mainly me, Frank, Joel, and Andy, who's going to be the one joining at the bottom half of the hour.
Okay, sounds good. So who's found something interesting in the last couple of weeks since the last meeting?
Trying to think about it. What did I do the last 2 weeks? I missed our last meeting, but 2 meetings ago at the end, we were talking a little bit about identifying ways to extend Kubernetes and orchestration to lower footprint devices. Does that topic interest people?
I think it does. I think we may even have a few people on the call who are maybe authorities on that subject. It depends on whether, there's two flavors of that, either reducing Kubernetes itself or not using Kubernetes. And they're both valid depending on kind of it. The right thing for you is it depends. I think Frederick here has given a talk on that subject at least a couple times that I'm aware of.
Yes, I did. And yeah, the ultimate answer to the question was it depends, because of course, anything that has to do with actual mission critical real-time requirements, even the Linux kernel, just the Linux kernel doesn't cut it for that in the eyes of some people, even with the preemptive patches and all of that. So of course, adding a container orchestrator on the top of that, ruins the whole story from a real-time perspective. That said, you will likely find it somewhere in the infrastructure or in the overall architecture of solution anyway, not necessarily in the robots doing actual wells or all of those machines with computing capabilities, let's say, or connected machines that you could find in a factory or industrial infrastructure. But certainly how do I say that? The border or the threshold for Kubernetes use versus something else is malleable depending on the use case, I guess. Yeah. So some of the work that I've done has been interacting with real-time operating systems with Kubernetes. So one of the things we explored was creating a custom resource definition so that we could use MCU boot to do an OTA update of a microcontroller running Zephyr. So it would trigger the second partition to flip over and do a reboot so that you could be into another workload. That second workload happened to be TensorFlow Lite being downloaded to the microcontroller, so it could do some very primitive gesture recognition. Another approach we tried was using Kubernetes to talk to VxWorks to do application over-the-air updates. So you could download new real-time applications to VxWorks. And
We've also sort of explored with the idea of eliminating some of the APIs that the kubelet has access to, so that it only focuses on the core Kubernetes API set, which could be interesting for a lot of use cases where the far edge device doesn't require any dynamic orchestration during runtime. And we've been experimenting with some of those things to really sort of push the limits of how low we can go.
Have you put together some kind of framework to do this, or are you assembling this out of off-the-shelf commercial or open source components?
We're not putting together like a separate framework. We're trying to stick to stock Kubernetes wherever possible. So I mean, the CRD was custom, of course. We used the generator, the Open API generator, to create a different set of bindings in some cases, because we obviously can't use Golang on some of these very small devices that have deterministic requirements. But so as far as I can think, it was like 100% vanilla Kubernetes and Kubernetes APIs.
Okay, so just to make sure I understand this, it's what I would call in the traditional control application, what they used to call or still do supervisory control, where you have a high-level control loop that gives objectives to the lower level devices that are actually where they execute them with real-time reaction parameters, right? Mm-hmm. So you're using Kubernetes kind of as a API framework to effectively build your own API to control the actual devices in a supervisory mode. Is that about?
We've experimented with both. Like with the small microcontrollers, your comment is bang on, because we would have like a Linux gateway to run the kubelet, and then the CRD would use the kubelet running on the gateway to interact with the microcontroller over Bluetooth, because there's that air gap, literal air gap between the two. But we also have done experiments where it goes beyond just supervisory control. And we have done a number of different things to play out different scenarios where the SLA for one device might fail, and we actually have orchestration going on in the background to fall back to another device that is able to meet the objective.
Well, I have to say that being in this group for years now, that going down that path, by my observation, is really common. That you don't have to be nervous that you're the first one to ever do it. It's almost maybe a little shocking that there aren't more standardized ways of doing that, like off the shelf, where somebody has turned that into a platform so that users one at a time don't effectively go do the research. There might be an opportunity for some kind of more opinionated solution that's been proven with reference architectures, but so far as I know, it doesn't exist, at least kind of in the open source community. There may well be vendors and system integrators who've done this in commercial engagements who could come in there and tell you that, yeah, we've got this thing ready to go for you, and they reuse the pattern that they've used in the past. But I'm not aware of an open source project that has put this together in a package that is well documented and ready to use.
And that hits on the reason I wanted to bring it up. I mean, making sure that we adhere to the standard and create some sort of open source standard for people that want to do this is something that we'd be interested in. In particular, when I started looking at the worker node requirements, there were some things that make perfect sense for a standard worker node that may not be required for some of these far edge devices. Like, for example, perhaps you don't actually need an overlay network because your small little microcontrollers may not be talking to each other directly. They may just be talking to the supervisor, to use the terminology you use, Steve.
Yeah.
So I'd be interested in sort of figuring out whether we could define some sort of leaf node or device node in the specification so that we could say that we were adhering to the standard.
And yeah, I see you have your hand raised.
Hi, yeah, Liam Randall. I work on WebAssembly and Plasma Cloud. longtime Kubernetes person as well. Rob, have you explored, using WebAssembly or Run WASI or any of the, WebAssembly tools on the real-time OS stuff in your work here? And I apologize, I was a couple minutes late onto the call. I'm not sure if you already covered that.
That is something I'm interested in, both WebAssembly and things like eBPF or UBPF, depending on what the scenario is. One of the restrictions that we face is we often work on safety critical devices, so the languages we use need to be certifiable. So that restricts us in some regards.
Yeah.
Then compared to more traditional device management solutions or platforms, what is the advantage from your perspective in taking the Kubernetes way for to orchestrate those kind of things?
The main advantage that we're perceiving is the ability to have a single pane of glass for all of your devices, so that when you're looking at your enterprise IT systems and your OT systems, you're able to have those currently separate teams come together and do common planning for how you coordinate software updates across all those systems, how you roll out security fixes, and how you make sure that you're able to keep all of your systems up to date using the same sets of policies and procedures.
Yeah, that makes sense. I was expecting that, let's say, but in any case, yeah, I was wondering how you viewed it yourself. Thank you.
So it's less about running things really natively on Kubernetes on one of these small nodes. I think that started off with, it's more like controller layer that would be Kubernetes. Because to me, that sounded a little bit like what they say cross-plane folks or the likes are doing, so that you can go and represent everything as a resource in Kubernetes, including small sensors. And I saw a demo a year ago where they had actually real container ships represented as resources in Kubernetes, and they were able to go and orchestrate them and manage them, which ship is in which landing dock and whatever, anything that can be a resource, right? So I think that's more like your use case, Rob, right, where you use one generic control plane for, well, virtually any endpoint, rather than you're trying to go and run Kubernetes on this endpoint, right?
Yeah. I think, Frank, you're exactly right, but once again, it's a continuum kind of based on how much resource you have. So some of these things that people call edge have enough to effectively run 3 nodes of compute, 3 Intel NUCs or something, in which case they can be a Kubernetes cluster and it can make sense. But others, I think it becomes kind of a gray area when you get to 1 compute node. You could run that as a so-called single node Kubernetes cluster. You have to ask yourself, and some people, it's a solid debate as to whether it makes sense. A single node Kubernetes cluster actually makes sense, because if you look at the components, how much of Kubernetes is actually delivering value versus just overhead and points of failure, points of security risk. Like I say, it's a gray area. Some people do it anyway, and it works for them. And then you get down to low resource where it can't even run 1 node of a Kubernetes cluster, simply not enough CPU and memory, and really low, it can't even run Linux. And Edge is so broad that it can include all of these, and one organization's demands could actually need all of those simultaneously. You might have some edge nodes that have big resource, but others that are just very tiny outposts. And a solution that could embrace them all is attractive, because there are going to be situations likely that at least your IO devices probably need to be managed. If they're smart at all, they probably have security risks and updates, firmware. And if your one system could do all of that, that would be really attractive. So that I think even some of these people with 3 tiny Kubernetes nodes still have additional smart IO devices that they would like to also manage in I don't know, I hate the term one pane of glass because it really isn't a world where operators are involved at the scales we're talking about, but one overall supervisory control plane that can put all of these things together. Like I say, I don't think that there's a solution. Maybe that's a good thing because the technology at Edge is certainly evolving rapidly. So locking in a design early might be actually undesirable. Things like advances in microcontrollers getting smaller, cheaper, lower power, WebAssembly being universal across CPU boundaries, but they're sort of all like bit spot solutions to one aspect of the many problems you have. And, you know, no one has, there's an opportunity for somebody to do an over embracing suite, I think.
So I would suggest perhaps writing out the requirements or standards for that leaf node or device node might be a good place to start. Is there anyone that would be interested in doing that with me?
I'd work on that. I mean, we've been working through this problem, you know, through WebAssembly, and I think we kind of hit across the continuum. You know, we obviously support Kubernetes out of the box with CNCF WASM Cloud. You know, you can deploy natively or via operators right there. But where we definitely see the biggest opportunity is way down market or in complex devices. Think like the AMD Xilinx FPGAs. You know, they've got multiple processors on them. You know, you look at the different lines of processors that ARM builds, for example, they've got the real-time CPUs as well as like the server side or mobile CPUs as well. And you often find these things integrated together in complex packages. So I do think that starting with defining the domain and what are the characteristics that sort of would be a far edge versus a middle, I think would be helpful. There is an awesome, you know, Linux Foundation sub-project that I'm sure you guys have seen, that infographic of, you know, that they did for the Edge, Edge across, and pull it up real fast here. You know, we, you know, kind of made a custom version of this. I think that includes browsers, so it's a little bit more WebAssembly focused, but I know that we're not the first people to have this discussion, so it's probably worth looking at some of the prior art in and around the ecosystem here. In order to see what people have done. If I could get screen share, I'd show this image real fast and folks could take a look at it.
Hey, just a minute.
Yeah, sure.
While he's doing that, I think that sounds great, like identifying all the different permutations and combinations. I liked what you said about the ARM Cortex R series, because in that scenario, you might have the kubelet running on the A core. Yeah, and then you might be using something like RP message to send messages back and forth between the two and trigger like a update of the workload on the R series. So those would be things that I would love to explore. You and I are thinking exactly the same here on, you know, I mean, these are the brains behind like 5G, you know, things like that. When we think about the last hop before you get to a device or on a device itself, you know, that's essentially what you're looking at. And this is from the Linux Foundation. They have a whole separate working group that where this image is sourced from, and we made a custom version of it. I'd be happy to open source if we wanted to tweak one, because we also threw, in our version, we threw browsers in there because we feel like, you know, things like WebAssembly really just give you the world's tiniest virtual machine, so that you can think of a browser or other non-traditional execution targets as a domain where you can be operating devices. But I think that certainly is a different definition than what you would use if we were thinking about where does Kubernetes work, and in a world dominant, you know, where just Kubernetes is an option, we would have a lower bound than if we bring in WebAssembly, for example.
Can I ask you a follow-up question on that?
Sure.
Make sure I get this proposal straight, but using a browser to host WebAssembly, is this something you would think for Edge could be something where the browser is effectively the equivalent of a Docker runtime for a real low resource thing that is already there, guaranteed to be installed in the OS, and you're not even using as a browser, just something you'd invoke to run a piece of code?
Yeah, absolutely. Let me give 2 examples of that. So Adobe did a case study with our open source Wasm Cloud. And one of the big takeaways, this was in background removal as a microservice. One of the big takeaways was that in over 80% of all cases, they were actually able to push the workload into the customer's browser. And that meant that it was faster because you weren't uploading images and back. That's 400 milliseconds versus just pure browser is 40 milliseconds. It was cheaper because they weren't paying for the compute, and it was the same quality. So I think that's where WebAssembly and Kubernetes really start to tell the better together story, because on their back end, Adobe is all Kubernetes. So they're able to seamlessly, run workloads that extend in both ways. This is your first part of the question. In the second part, I would point at, when you're looking at, some of the modern edge type people like Fastly uses a runtime to run their compute products for WebAssembly that's called Wasm Time, and that's from the BCA. But Cloudflare actually uses headless. They use V8 in running their WebAssembly processes. So they're actually using the core engine out of the browser. The other big engine is SpiderMonkey, which is the engine behind Firefox. And I think that may be what Node is using underneath the hood for its JavaScript processing, for example, but don't quote me on that. Node might be a separate implementation now, not 100% sure. Did I answer
Forage, though, I would suggest people might want to use like the Wasm micro runtime instead, just for these small devices. I've seen some people try to connect to that with MQTT as the control mechanism to download the WebAssembly modules, but it'd be interesting to make a more generic version that used Kubernetes in the place of MQTT.
There's a couple projects that integrate this directly into Kubernetes. There's if you wanted to run WebAssembly natively, I'm going to do some big air quotes there, because the deeper you get into Kubernetes, the more you discover that Kubernetes is really tightly coupled to the idea of a container. But there is a shim that's called Run WASI that is a part of the CNCF that does enable you to sort of natively orchestrate WebAssembly on there. And then projects like Wasm Cloud, which rides on top of NATS for its communication side to side between hosts. Actually, we have Kubernetes operators and things like that for pushing and deploying as well. So I think there's multiple strategies depending on the architecture and what you're looking at. NATS does speak MQTT right out of the box, which is one of the reasons that we selected it for our sort of transport layer between hosts.
So Liam, to summarize, I see that there's the transport layer, kind of the orchestrator that would tell a leaf or an edge node what it wants running and what version, and the observation that perhaps you can use a web browser engine to be your runtime for the WASI. But what about actual containerization of it? And by container, I don't necessarily mean Docker container, but maybe I do mean OCI, because it strikes me that you still need packaging for these WebAssemblies where you have provenance signing and all that kind of stuff. And
that's a great question. So this is the image that I'm happy to donate, a version of this that where we just put the browsers in if we wanted to, like add this in. I'll have our graphics guy is awesome. I'll have him just, release a version of this that we can just pick up and use, and we can customize our definitions and use whatever we want here. And lay Kubernetes on it as a layer more clearly or something. I've tried to do that here lightly, and that's our corporate cut sheet kind of stuff. But when you're thinking about how do you move these WebAssembly modules around, they are actually moved around as OCI artifacts, and there were huge reasons for this. We worked. If you look at who's in the Bytecode Alliance, it's Google, Microsoft, Amazon, and all of these companies have huge ecosystems around OCI, scanning of artifacts, itemizing artifacts, distributing, caching, all of those kind of things. Now, underneath the hood, though, there is a little bit more introspection that goes into WebAssembly. WebAssembly is really about moving around a unit called a component. And what's powerful about components is that they can be combined into new components, or they can be satisfied at runtime. So one of the big ideas that's happening behind WebAssembly is just write pure business logic and then deploy or attach your components for web servers, key value, and other non-functional requirements at runtime, as opposed to compile time. The advantage there is that you're obviously getting the latest version. And when you look at the DevX around like a Fastly or a Cloudflare or my company Cosmonic, that's really what we're driving for as well, which is, containers are great, but we're really driving for that next higher level abstraction where you look at the common complexity that is, the things that the 95% of the source code, that's all open source that goes into each and every app. That's the really kind of big idea there. But underneath the hood, it is tightly coupled and aligned to a better together story with Kubernetes. I'm chair of CNCF WASM Day as well. And we actually just announced WASMCon recently, and I'm sorry, I'm trying to turn this into a WebAssembly call, just on things that I'm super excited about.
Yeah,
So
feel free for your WASMCon and other things that maybe the time is limited to drop links to that in our Slack channel or and also in the agenda notes document here that you got the link to, so people can find
I'll do both, and I'm happy to act as a resource if people want to pick up offline and really introduce you to even other projects as well outside of the ones that I work on. I'm just really passionate about the rising tide of WebAssembly lifting all boats.
Well, this sounds great, injecting this into the birds of a feather, and my personal attitude is maybe I'd like to turn this into a longer discussion. If you want to put yourself on the agenda for a future meeting, to go into this in more depth, our agenda is open to members to just self-nominate things. Just go put it in a future date. If the dates don't go out far enough to you, just edit that document and put it at the right 2-week interval by cutting and pasting an older one as a template and go for it. And
Okay.
if you wanted to start an organized thing, under the auspices of the CNCF, or Frederick here represents the Eclipse Foundation too. And I've got nothing against having this be a joint effort of multiple groups, as long as they're open source, and or multiple groups in the CNCF, because I think there's a WebAssembly thing coming together under tag runtime, I believe.
Yeah, there is.
Kate Goldenring has said that. So this doesn't necessarily have to be pigeonholed into exactly one. I think we could live with efforts that cross domains. Yeah,
we're plugged in there. Kevin, the creator of WASM Cloud, is the technical advisor to that new subgroup that's spinning up. So we have a couple of members that attend there, but it's just pure coincidence that I decided to start attending this. I knew we needed to, and I'm actually trying to work on a Wind River project right now. So Rob, I'm going to be DMing you after this call. I've already got questions about WAMR support on Wind River real-time OS.
Sounds good. I'll send you a message on LinkedIn too.
Yeah, cheers.
Yeah, I haven't seen you at any other meetings, Liam, but just another thing that might be of interest to you that came up a few meetings ago is that, one of the hottest topics going on here, and Edge isn't going to be left out, but it's AI and machine learning. And, to reinforce that, for this BOF, I was saying, what have you done cool? And I kept my mouth shut, but the coolest thing I've done in the last week is I went to my first physical meetup of what's called the Tiny ML Foundation. And they're having physical meetups around the world. And it's kind of astounding. ChatGPT gets all the popular press, but man, the amount of R&D being unleashed for edge machine learning accelerators, inference engine accelerators is just incredible. A few weeks back, I put references to ICs with accelerators in our Slack channel, and I came up with 16 just easily. I'm sure there's many more than that. Went to this meeting, and it was local Southern California, but there were about 30 people there. And man, everybody was excited. They were generally representing hardware vendors in the form of chip vendors, but the world is going to see some big advances there. Now, what goes along with this, I think, is a need to have a control plane and orchestration, if you will. Although there's yet another thing to be managed that I don't think Docker containers or WebAssembly is the solution, and that is getting updated training data to these edge nodes that are actually going to run it, and maybe bidirectional communications with all the typical challenges of low and intermittent connectivity with these edge nodes. But I think that this is going to be a huge opportunity, and the world is just really taking on some of these opportunities, at least in proofs of concepts, and early arrivals are having success from what I've been seeing at this.
Yeah, that's where, when you look at the the design of Wasm Cloud, it's really positioned around some of the native orchestration challenges, and with WebAssembly specifically. And we've been focused there. I mean, we've been a CNCF project for a couple of years now, and we've exceeded the effort to go incubating. So we're in the process of applying for incubation now, which we hope will raise the kind of profile in and around the ecosystem. We've done we did a talk at ARM Summit in the fall, where folks from Intel and BMW had extended the WebAssembly standard to support interactions with machine learning models that were running in TensorFlow underneath WebAssembly. So it's sort of as a sidecar to WebAssembly, not in WebAssembly itself. But the logic was in WebAssembly in order to do, to route data to a local machine learning model or to a cloud-based model, depending on security, privacy, or availability. So I think that we're all circling around the same elephant and looking for all these amazing pieces of it that we can pick off. And I definitely think there's a lot of opportunity and greater collaboration, Steve, to come back to your point, and around open communities where we can build on each other.
And we're going to call this to a close because I think the people are here for our second topic. But Liam, just go back in the agenda notes and look at, might be of interest to you, of something from Sony Midikura that's an attempt to use WebAssembly to create an abstraction layer virtualization around machine learning inference engines. It's go back a few meetings, and
I've talked to the team a couple times. We're having a meeting already around the Wasm Cloud. Yeah.
Okay, so for the next topic, the discussion of the Edge Native Application draft white paper, who wants to run that? If you're not co-host already, I'll give you that permission.
Well, I can start off introducing the topic, but I think Frank or Andy should probably share their screen and do the running through.
Well, Brandon, I saw that you did a couple of tweaks and polished the thing, so maybe you want to even share.
Yeah, I'd be happy to start things off.
For late arrivals, when you drop another link, I already did it before, but drop a link to the document too, because we had some people join a little late.
Okay. Yep. Do that. Oops, you don't need to see my messy screen. Okay. Put a link in the chat. And I'm now sharing my browser. So to remind folks of what this is, a group of us have been meeting now periodically over the last few months to further develop the idea we had of a supplementary paper to go as an accompaniment with the original Edge Native Applications white paper that was published a while back. And in talking about using that paper as a foundation, we thought about what would be the next logical extension of the topic in order to produce an asset that would be valuable for the ecosystem. So rather than modify that original paper, which we all think is still a great foundation, we decided to create a supplementary piece with a focus on design behaviors for developers to put those Edge Native Application principles into practice and make them more actionable. and to be used in accompaniment with the original white paper as a guide for developers designing and building applications for the edge. So we had a discussion here with this forum, I think it was about 5-6 weeks ago, where we talked through the concept and an early draft. We then collected feedback live from that group and then shared this draft of the paper on the Slack channel and with the Google group. Since that time, we've seen comments coming in, and we've now reconciled the majority of those. I think there's still a few comments down below that we can maybe talk through here today. But then just following sort of the same process as last time with the creation and finalization and publishing of the first white paper, I think we're at the stage now where we're presenting this as our proposed final draft back to this group. We can take this opportunity to incorporate any final feedback from the group, and if desired, we could leave this doc open for a little bit longer for any additional comments or questions from the
maybe
community.
if we could declare a tentative end date so people know what their deadline is for getting their review comments in. And
yeah, that might help. So maybe at the end of this call, we figure out how much time we might need to cut things off in order to move things forward. But for my role here, I just took the opportunity last night to go through the paper again, provide an edit, a very light edit for clarity, for flow, and a proofread. And in order to sort of match the format of the last paper, I added an author and reviewer section to page 1 and included some names of folks that I know are working on the project. There might be some names missing here. So I would encourage anyone who, for instance, has reviewed the doc and has contributed to go ahead and add their name here as a reviewer. And we want to make sure that everyone who's contributed is being captured. So that's a request to the group. And then once we figure out a published date, that's something that's finalized there at the end. And then as we wrap up with this group, I'll then channel the work over to the CNCF marketing committee. And they have a designer team there who can put this into a PDF format and then work into their upcoming promotion schedules like we did for the last white paper. So that's what I had. And I know that, Frank and Andy and Joel have been pretty instrumental in getting this paper to where it is now. So I don't know if one of you gentlemen want to pick it up from here and talk through where we are and maybe talk through any final questions or comments that the group might have.
Frank, you want to do some like basic introduction and I'll add color along, and Joel and I can add color?
Yeah,
You're good at framing things.
you think so? Okay, thanks. If somebody hands you flowers, you always got to be careful. No, but I think the main. So we've been through this high level flow already. So as Brendan was saying, like we are trying to go and have this white paper complement the original white paper with the principles to go and help people design an application to be quote unquote edge native. And when we did the review here in this group last time, we said, well, it would be really helpful to have an example, like an anchor or a beachhead that we can go and use, an example application that we would then say, okay, this is how you can go and architect and use these, both the design principles as well as the software application design behaviors that we're distilling in this white paper, and well, make that a reality. And if you scroll down to the very bottom, that's the main addition that we've done over the past couple of weeks. If you go to the very bottom, Brendan, then you'll see that section that says, don't even recall the name. So we still have these individual behaviors that we're calling out. And yeah, we have this edge native application sample scenario. And the scenario that we're picking is one that I think many applications use today, where you have the situation that you're acquiring video at the edge, and that you need to go and turn that video signal into information. And that includes something that we discussed earlier on, typically running something AI or another way to go and interpret the video and turning that into a signal and uploading that signal to the clouds where it's going to go and get further processed. And that might be for bandwidth reasons that you do this, or it might be for reasons of privacy, regulatory policy, that you want to go and do that processing at the edge. So we basically said, okay, well, let's take this very simple application where we have an edge portion, and that would live at the smart device edge, so relatively far out, where you know that this side is going to be detached. It's every now and then where it might not have a load of upstream connectivity, where the upstream connectivity might be constrained over multiple layers of NAT and what have you, where we would acquire the image, then do some processing on it. That might be simple resizing. It might also be more sophisticated AI models. Then you upload the results, and then on the cloud side, you take the input and then you do further stuff with it, right? So we try to go and come up with a very generic architecture for that. And then if you scroll further down, then say, well, the original design principles or behaviors that we had, how do they apply to this particular use case, so that things become really like more, that you can have a way to mentally attach to these individual design principles and design behaviors in a more natural way using this example application. Yes, it's a very simple one, but simple, I think, is not necessarily bad here, because it probably resonates with everybody. So we're saying, like, what do I need to go and do for concurrency and scale? What do I need to go on for articulating dependencies? How do I deal with failures at the edge for that particular application? How do I deal with the fact that edges need to go and be able to discover their environment and be aware of their environment? Like, yeah, well, discover the endpoints that you're dealing with from a sensor perspective. In this case, that's the camera. How do I deal with storage? I.e., you don't want to go and persist data at the edge. You want to persist data in the cloud. You only want to go and cache, so that the disposability of the edge location is still a given. How do you deal with metrics and logs, i.e., well, only expose actionable logs because we're assuming a non-expert operator at this very far edge. And that dovetails with the operational piece. So I think that's the main addition of what we had. So making the additional the behaviors that we distilled from a white paper perspective, making them say more visual or more articulated by using this simple example.
Yeah, so Frank, just to back up on that, I think we were also talking about, if you scroll up just a bit, Brandon, to the tiering discussion here. So this is one of the areas.
That's a very good one as well. Yeah, I forgot about that. Thanks for that.
No problem. I'm gonna dovetail that in because it adds a layer of complexity here. So yeah, so one of the other things that we talked about, within the working group, is that there was this notion of, well, today people are very much used to hub and spoke, but when you get into spaces where disconnected operations is more, a familiar concept, like oil rigs, offshore, cruise ships, interstellar communications, et cetera, becomes this notion of, well, I may not have direct hub to spoke access. So what happens when I have to introduce more tiers? And then that's when we got into discussing about, and this kind of overlays on the existing IoT paper that this is an addendum to or addition to, is that the discussion about, this notion of intermediaries or ESPs, edge service providers. And there may be multiple of these that are in the middle that provide either some kind of DMZ, where there's a division of responsibility matrix between what is the hub responsible for versus the spoke, or it could be just merely a transport layer that's ignored for the sake of targeting deployment of workloads, and it's just used as a means to get to the outer edge. And this could be something, I mean, Steve, you've brought this up in the past. This could be just somebody like that works on an agricultural setting, that has a cell phone that collects all the data, and then at some point in the future, they're going into town to get supplies, and they happen to brush up against the Wi-Fi or some kind of cell spot, and then are able to transmit data. That's not something you really, could connect with a hub and spoke model, but it's something that we're thinking about in more of, add these intermediary layers in between. And it gives a lot more flexibility to those that are building edge native applications now and in the future. Just as because you just scroll back down, Brandon. So you could imagine applying that tiering all the way down to the bottom where there's a graphic, I believe, that Joel supplanted. So you can imagine putting an intermediary tier in the middle of these two gray boxes here as something that sat in the middle and provided some layer of abstraction or layer or means of transportation between the edge and the cloud provider or the cloud space.
And that's, something Joel, sorry to put Joel on the spot, is still working on, right?
Yep.
Yeah, I was about to say that. I was about to do that myself, Frank, but thank you. I liked your comment about careful when somebody hands you flowers. But if you take this here, it has an example of a single edge where the text stops at the bottom is just putting sample building on that to give example deployment models of here's one edge, here's what it'll look like. This has to get added. Then I have to add. Here's what one edge looks like, and now here's what, this goes out to 100, maybe 500, and building that from one edge to a region to global. If that made sense, the gist of from one location and how it scales. And to Andy's point of here are the different tiers and what that might look like. And again, the intent is to provide an example that people can then go and utilize for whatever their specific project is.
Thanks, Joel. Didn't mean to throw you under anything. I knew it was coming.
No, it's all good.
Okay.
It's all good.
Yes, that's all I had for comments too, Frank and Brandon.
Just to
Was there a
note that
question
I
that just scrolled past? Was there a question? Sample scenario looks really interesting. I will definitely take a look. Okay.
Hey, I just added a comment. You can look, I got long-winded like I do verbally too, but my comment was that there is a section there that appeared to me to ban persistent storage, declaring that all data is persisted in the cloud. And it struck me as maybe too authoritarian, that there are use cases where for legal privacy reasons, you explicitly are maybe even doing your compute at the edge specifically because you cannot have data persisted to cloud, and that this should be open-ended to allow for those scenarios. And as I was writing my comment, it occurred to me that it would be better not only to allow it, but maybe to add a layer that would say that you should be labeling this stuff so that you could provide a hook to do auditing and policy enforcement. So explicitly declare that you've got this data, maybe it's the standard data, is cloud-backed and the edge only holds, is viewed as a cache, but perhaps allow for another category that isn't allowed to leave the building or the edge node. And clearly it does exist, and there are use cases for that. Maybe even it isn't a privacy legal concern, but simply bandwidth or something where up front that the stuff is just bulk data that I'd rather lose it than pay for the cost of moving this up to cloud.
No, I think that's a good point, Steve, that you bring up. And I've seen these use cases as well, like largely around like anything regulatory, privacy, whenever those concerns are arisen, or even security, then data needs to go and stay local and be persisted local. But maybe we can go and frame it as another category, as you say, because what we want to go and continue to have is this separation of compute and data, so that we can scale compute in 2 dimensions now. One is like within an edge location and even across the many edge locations. And we would lose the ability of disposability if we make the application itself persist data. But if we separate the code from the data and say, well, we would assume that there is indeed an instance of something that can persist storage at the edge, which is separated from the application that is and we are basically talking application design principles here and the design behaviors.
Would perhaps titling,
we
I'm
can
looking
go
at
and
the
couple
screen
these
you're
two,
sharing.
like loosely couple them at the edge and then bring up another category there. Sorry.
Yeah.
Yeah.
So on this screen share, I'm currently looking at the section is entitled data storage. You maybe could entitle that cloud-backed data storage, and it's an optional feature that you need. Maybe you usually use it, but
Yeah.
don't declaratively state that that's all there is and that's all you're allowed to use.
Now we need that second category, and we should go and reflect that. I think that's a really good point.
Yeah, it's a great point.
I think the key thing is the separation piece, so that I can go and continue to fail processes, that I can even fail entire clusters, whatever, and that I persist the data somewhere else.
Right.
And if I persist the data in the cloud, or if I persist the data in another instance somewhere at the edge, that's perfectly fine, right? I think the key thing is the separation, and that we can keep that separation even if we go all the way to the edge, rather than bake the data into the application again, which is like not a good idea, I think.
Yeah. So, cloud-backed data storage might be one of these categories.
Yeah.
And then edge-backed
we need this
persistent
somewhere
storage
else.
might be another. And that could either be 2, well, probably more likely 3, but it could be 2, just a mirror at edge, where 2 edges in the same, call it political domain or something for data privacy restrictions, could back one another up, and it's better than no backup, right? And okay, I like that, but I think maybe this has room for improvement.
Yeah, it's too strongly worded, definitely.
And then the other thing that maybe you call out is, as I read this, it struck me that this was more going down a path of it being kind of application layer, time series centric kind of data. But there's another category of data which I would call kind of the control plane, the desired state configuration and that kind of thing. Those are a form of data storage, that are aligned with the control plane more than the application plane. But they still have this same thing where presumably, even if you're using something like a GitOps, the Git repository in the cloud is the authoritative single point of truth. And the stuff, you might still even have a small Git repository down at the edge node that is effectively a cache that is getting populated from the cloud. But would calling out data storage use cases for the control plane itself, as opposed to the applications, be a useful concept? Because I think they might use, they'll have different governance models that would be desirable, and maybe even different places and ways they're stored. So the control plane might store in Git, but for application level data like frame by frame video or something, that's unlikely to be appropriate for storage in a tool like that. Just brainstorming here on this, and maybe there's a downside. Having worked on the other white paper, is the more you think about this, you run into the level where you don't want this paper to become an encyclopedia and get monstrous, but throwing it out there.
No, but I think there's room for terminology here, right? I mean, a system of record or source of truth, as you put it, like GitHub or etcd, depends on which, you're choosing, or maybe you use both, is different than, categorically different than application storage, right? So it may be useful to think about the not only the mode, right, the sovereignty versus non-sovereign data, but it also is useful to, I think about the categorization of the data type as well. And so I think it's all useful here. It's good color. Victor had his hand up.
Yeah, I always wonder, maybe all this paper, is this about far edge or edge? Because when we talk about edge, my understanding, there are different categories of edge. Like, for example, if you have a training facility in the football field, you have an application that's provided by a remote cloud provider, right? That's still edge. However, there's a local database that's persistent. So, and yeah, and there, similarly, there's the original Edge paper about Edge native versus cloud native, saying that the Edge native is primarily monolith rather than microservices. Does it apply to all Edge cases, or is that just for specific? I know, for example, for WebAssembly applications, that might be true at this moment, but is that true in all cases? That in Edge cases is not microservices?
I don't think we double click on the monolith as an edge here in this particular paper, but my answer to you is what, the old famous saying, it depends, right? I mean, I don't know that we necessarily prescribe any particular architecture type for what should be on the edge. And I think you're right. I think it could be, in many cases, you see like K3S, or you see Microshift right down there. They're very happy to run in microservices rather than in a monolith, or run a monolith. So I don't think that we're in any position here in this paper, and I don't know if we've done it at all in the paper. I can't recall. Maybe Victor, that we've prescribed it being monolith versus microservices, if that's your question. Is that your question, Victor? If we're prescribing one architecture type over another? Wow. I think I pushed Victor off the call. I pushed him to the edge.
Running up against.
I think we're hitting the top of the hour. So how do we want to go and continue? Because I think many of us probably have another call. So we go and continue the discussion, Steve, next time?
You're welcome to do it. I don't think there's anything on the agenda for a meeting in 2 weeks, and I think you don't want to necessarily, kick it too far downstream. We said we'd make a declaration of how long you're open to comments too, so we haven't heard that yet either.
Yeah, well,
maybe
let's
do it
that next time once everybody's been through the text, and then we understand all the comments, and then we can go and update from there. I think it would be good. So that everybody had a real scan through, and then we can go and discuss.
Okay, let's do that. Let's put you on the agenda
and then see how much runway we need, right?
Yeah, I asked a question and then lost connection right after. So yeah.
Anyway. No worries.
We'll get it in now. I think we started at 4 minutes after the hour, so you've got 2 minutes, and if it's not enough, we'll continue it at the next meeting.
Yeah, I guess mainly is I'm still not quite clear. This edge, is there a category of edge? Is this just about far edge or about any kind of edge? Because there's a lot of different definition about edge computing.
Yeah, I think it should be applicable at far and near. I think you have a slide rule there. That's my thought.
The key thing is like whether you can treat the edge as an extension of the cloud, where you don't need to go and change anything from a principles perspective. Then that could be like, it's not really the location. I think it's the qualities of that edge. If that edge is like suffering from limited, low, whatever connectivity, from specific policy constraints, from specific security constraints, then I think we need to go and do something different than just treat it as an extension of the cloud. And I think this is where this applies. So it doesn't necessarily say, well, it's only far edge, it's only near edge, it's only smart device edge, it's only, we can go and, expand that further in next Wednesday. No, week after next Wednesday.
In 2 weeks, yep.
2 weeks. All right.
All right.
Thank you so much. I think this
We can
sounds like a
continue.
fun and lively discussion next time, and then we can for sure already do some couple of tweaks, Steve, based on your feedback and everybody else that chimed in so far.
Okay, well, thanks. I think this was valuable, and we'll call this to a close. Bye, everybody, and see you in a couple weeks.
Thanks all.
Thank you.
Good time.
Yep, bye.
Cheers.
Bye-bye.
Thanks.